Hello guys, this tutorial is on how to make the controller follow the skin. Because for now, when I open the mouse, the controller doesn't follow the mouse when it changes the shape, which actually doesn't mean they're not working. You can use them to control the parts easily, but they're just not following, which may seem a little bit counterintuitive for the animators. And it's raining outside, so sorry about the background noise. Okay, but let's see how we can actually do that. The idea here is actually very simple. What we need is use follicle, and the reason we use follicle is because it's pretty cheap, and then it follows the skin in whatever way the skin deforms, and then we just make the controller follow that follicle. Okay. So let me go to the FX and then in here and then create here. I'm going to use nervous curves, and then I'm going to use U1 V1, just one. Okay, and then non-static and non-dynamic, which means static, and then apply. That way Maya will create a follicle right here. Okay, if you go to the outliner, Maya creates multiple things like hair system, output curve, and nucleus. I don't need any of those, but I need this follicle. Okay, and this follicle have a curve underneath it. I don't need that either. Okay. Now if you select this follicle node, you see that it does have parameter U and V. Okay, meaning that if I want to move it somewhere, maybe on the mouse, maybe that vertex, what I can do is I can go to the modeling UV editor, and then I can grab that one's UV, and I can see its UV is 0.4, 0.8. I can of course copy this value and apply that value on the UV parameter. And then I will be able to move that follicle right to that point. If you look at it now, it's right up there. Okay, so then what I can do is I can use this follicle to do a point constraint on the controller's group. But my controller already have some locator and top group on it. Let me just group it one more time, and I can name this group the follow group. Okay, and then I can use the follicle, and then I can select the follicle and then the follow group, do a constraint, one constraint. And then I need to use maintain offside because they're not at the same location. Okay. That way when I drag my other controllers, it will follow. Okay. But there is a problem though, which is when I drag the controller itself, it's not only moving once but twice. This is called double transformation. The reason causes that is because when you drag the controller up, the controller moves up itself, right? But on the other hand, its parent is being point constrained by the follicle, and the follicle moves, so the parent also moves. So basically, the controller moves itself, and then the group of the controller also moves, and that causes the double transformation. So how can we fix that? Well, you can also group our controller again at this time. Let's name this one compensate. Okay, now this compensate GRP will compensate that double transformation. So what we can do is go to Window Outliner Node Editor. Let me clear that, and then add my controller and the new compensate group here. And what I can do is I can make the compensate group go to the opposite direction of the controller all the time. So that means I need a multiply divide, and I need to connect the translation from my controller to the multiply divide and multiply that translation by -1, and then the other, sorry about the the lightning strike. It's raining really heavily. But the other side, it will be connected from the output to the translate, and then the input to axis will be XYZs will be -1. So now the controller's parent will always go to the opposite direction. That means it's compensating the double transformation. Now if you drag the controller, you see it's following perfectly. No matter what controller I'm dragging, it will always follow the skin. So that's the basic idea of doing that. It actually only takes you 5 minutes or so to do this for one single controller, but we will have a whole lot of controller on the face, and that means you need a whole lot of 5 minutes to do that, which is not cool. So let's see how we can do that in a coding way. Okay. So I already have the coding here. Let me walk you through the entire process again with the Python tab. So import my.cmds as MC. Okay. Now I need a couple functions. The first function I need is create follicle. Okay. So let me define that. Define create follicle. I need a couple of arguments. The first argument I need is what geometry I want to create the follicle on, which is my geo. Okay. The other one is the u direction, v direction of the u and v direction of the follicle, or the u v coordinate, or those two values. Okay. And then I probably need a name base, so name. Okay, now I need those three variables, and then I can start creating it. The first thing I want to do is create follicle equals MC dot create node. Okay, I'm gonna create a follicle node. So I need to have two parentheses and type in follicle. Okay, that will make my create a follicle, and then we can name the follicle by using the follicle name, and then just plus a shape, because this is gonna create a shape node. Okay, let's run it. Let's call this create one follicle. Okay, because I have one already there. Just gonna, you know what? I think it's okay. Just create follicle. So let me call it right here, and then the geo will be my geometry here. So I'm gonna give it a argument like this for the geometry. U, let's just do 0.5, and V also 0.5, just to test it. And then the follicle name is test follicle. Okay, let's run this code. Got an error. Object test follicle shape is invalid. Oh, sorry, the name equals that. Sorry about that. Let's try that again. What that does is now it will create a follicle called test follicle. If you go to the window and then node editor and see the input output, you see now we have actually the test follicle shape and then the test follicle created, and then they are just there, so they're not connected to anything yet. If you look at the head follicle we created earlier for that controller and see its input and output connection, you see it's actually connected here. The input connection to that shape node is out mesh to input mesh, okay, and word matrix to input word matrix. The output is from the follicle shape node to the follicle node, out rotation to rotation, out translate to translate. So we need to mimic that to our new follicle here. Okay, so the new follicle have to be having the same connection just like the other one. What's that weird thing? I have no idea. There is some glitching on my Maya window. Seems like I cannot get rid of it. What's going on? Let me pause the video and then go back. Okay, sorry about that. A weird bug there. Maya is buggy. In my opinion, it's buggy. It's just buggy. No excuse, but you know, I don't know what they're doing. Apparently not a very good job. But anyway. So let me drag my script editor here. Hopefully it will be okay this time. So we need to do the connections. Let me start with the input connection for the test follicle. We need 2 connections. So let's do mc dot. Oh, before I do that, I also need to figure out at least where is the shape node of the geometry. Right? We only have the geometry node, so geo shape node will be mc dot list relatives. Okay, the relative we're listing is from the geo we passed in, and then the relative we're listing is the shape. So as equals true, it's gonna return a list. I need the first one. Okay, and then let's also figure out where is the actual test follicle node, not the shape node, the translation node. So follicle translation node will be equals to mc dot list relatives. Oh. And then we're looking for the follicle. I think I tapped that word wrong. Should be having double L. Okay, so follicle. This time we're querying its parent. Okay, and then we also need the first one. Okay. Just to be super safe, let's print out their name. So let's print the geo shape. It's gonna be the shape of the geometry. Let's also print out the follicle translation node. Make sure we're getting those 2 correct. So let me go and delete the ones I created earlier and run it again. Now you see it's printing out 2 things: the head geo shape, which is this one we're gonna use. The other one is the test follicle, which is the translation node. So we get everything correct. Okay. Printing is really useful when you're doing programming. It tells you the information you need to check. Now let's do the actual connection. You can actually just drag the connection there to see what attribute is connected in code way. So it's out mesh to the input mesh. Let's do that. So mc dot geo shape, connect attribute, and we'll connect the geo shape plus dot out mesh. Okay, we'll connect that to the translation shape, which is our follicle, plus dot input mesh. Okay, so we're connecting those 2 attributes. Now the other attribute we need to connect from the geo shape to the follicle is word matrix to input mesh. Okay, so let's do that. You don't have to put in the square bracket though. So word matrix to input word matrix. Okay. So that way, let's delete the nodes again and then run this code again. We'll see that the new one now is being connected just like the ones we had earlier. Okay. And then let's do the other side, from the shape to the translation, which is easy, just rotation to rotation, and then translate to translate. Let's do that here real quick. Now we're gonna connect from the follicle plus dot out rotate to the the follicle node, which is this one, the follicle translation node. Okay, plus the dot rotate, which is lowercase r. Okay, let's do the same thing for the translation. So the translation will be out translate to translate. Okay. Now if I go delete those two again and then run this code again, I will see that both of those nodes are now connected. That means the follicle should work now. Let's take a look at the new follicle. It's at the origin. That's because I haven't set up the UV coordinate yet. So let's do that before we test it. Let's see. Maybe let's do it for this guy on the other side. Okay. So I need to see the UV values. It's 0.289 and then 0.847. Okay, so I need to also do that here. So mc.set attribute. Okay. Oh, I deleted that already. So let's just set that. It should be on the follicle shape node, which is the first one we created. And then it's going to be parameter u and parameter v. U, okay. That will be equals to the u we passed in. And then we copy this. This time is going to be parameter v will be assigned with v value. Okay. Now let's run this again, and you will see that the new follicle will be positioned to the position of that vertex we selected earlier. Okay. And now it should work. I should follow the skin. See that? It's following the skin now. All right. So the create follicle function is almost done. The last thing is you want to return the follicle's name you created. Let's do that by typing in return follicle and then follicle translation, because we created actually two nodes instead of just one. So it's better to return both, even though you may know that you only need this one maybe, but you also maybe need that one too. So let's just return both. And that's create follicle. So every time when you run this code with the corresponding arguments you need, you will be able to create follicle there. Okay. So that's the first function. The other function that I need to do is find out UV coordinate. Okay. Now to find out the UV coordinate, we can do actually another trick here, which is go. For example, we're doing maybe this one here. Okay, now it's really hard to find a point for that because none of the points around it is really close to it. So we need to find out the UV coordinate on the geometry that is the closest point to that controller. And what we can do is go to the rigging and then constraint. There is another constraint called closest point. If you create that, Maya will create two locators. One is at the origin, another one is on the model. And then when you drag the one on the origin around, you will see that the other follicle, the other locator will be always sliding on the face, and it's trying to give you the closest point on the model to the locator you're dragging here. See that? So that means if I select this follicle and then select the controller, and do a modify match transformation, match all transformation, and you see the other follicle will be positioned on the model, and that position will be the closest point to our controller on the model. Okay, now let's see what's exactly happening here in Node Editor. If you see the connection here, you see that the head geo is connected to a node called the closed point on mesh, and then it's reading the image and input matrix, and also it's looking for another position to sample, and then the result will give you the correct the position that is really the closest point from the model to the to this guy here, to the in position. The good thing about it is it's also giving you the parameter u and v. See that? So the uv coordinate here from the result of this closest point on mesh will give you the closest point and give you the uv coordinate of that point to the controller. Okay, so we just need to get this information, and that's gonna be the uv we need. Okay. You know what, let me create one and show you the results. So let's run this again. Okay, so I have a test follicle here, and the UV coordinate, if I use the UV coordinate from this one here as the UV parameter of my new follicle, okay, see my new follicle will be positioned to right there. See that? So that's really useful. And what I need to do is I need a function to create this node, connect the correct inputs, and then I need to read out the UV coordinate of this closest point on mesh node. And then I may need to delete those things because they're useless after I get the right information. Okay, so let's do that. UV coordinate define and UV coordinate. Okay, now we need to pass in a few arguments. The first argument is still the geo. Okay, the other argument we need to go for is the controller or the object. Let's just call it object. The object we need to sample from, which in this case is our controller. So the first thing we need to do is go create that closest point on mesh node. So will be equals to mc dot create node, just like the one we did earlier. So the node we're creating is this time is closest point on mesh. So let's copy this name here. Okay, and paste it in and delete that one at the very end. That's gonna create a node we want. We don't need a name because we eventually is gonna delete it anyways. So let's just let Maya give it a random name. So closest point on mesh. That way we can get rid of name clashing easier actually. So that's that. And then when we run this code, we need to actually run it by calling it. And then let's also pass in our geometry as the name. The controller this time, let's use the controller on the other side, which is this one. Okay, let's run it. Okay, and then what Maya will do is Maya will create this new closest point on mesh node, and then let's go do the connection thing. So the connection thing for the closest point on mesh will be first from the mesh geo. We're gonna do the word mesh to in mesh. Okay. connect attribute, and we're gonna connect the geo shape, which we haven't got it yet. Let's just copy this code here. Oh, you want to make sure your indentation is correct. So we're gonna connect from the geo shape, and we're gonna connect from its word mesh attribute. You need a dot there, and then we're gonna connect it to the image of the closest point. Oh, so this guy here. That's one of the connections. Another one is the word matrix to input matrix. Okay, let's also do that. Just switching the attribute here. So you see everything we are doing here is just mimicking what we do in manually using a coding way. So now we connect those two attributes. So let's run it and see if everything works. Oh, I got an arrow. Oh, sorry about that. Why did I do that? Plus, that's what we need to do actually. The dot is also there. Sorry about that. That will make it work. So the actual name of the variable should not be inside of any quotation mark. Now those two are being connected. Another input is the imposition. Okay, so how do we actually get a locator for that? Well, we can just create one very simple. So locator equals mc dot space locator. Okay, I don't even need a name. That will give me a locator. Okay. Oh, let's also print the name of the locator, just making sure we got the correct node, because it may give us two nodes actually. So let's run it again here. The locator is locator, so I just need, it returns a list, so I need the first one. Alright. When I print out, I see that means it's a locator. It's a list of naming. So I just need to get the first one. Alright, so now I got a locator, and then I want to do a match transformation. I match the locator to the objects. Okay, and after that we do the connect attribute. Gonna connect from the locator plus translate, and then that's gonna go to the imposition of the closest point, which is this one. There, translate to imposition. Okay. Alright, so that should take care of everything. So let's try that again. Now we have a locator also created. Its location will be matched to the controller, and that way we got the closest point on match all connected with the correct input we want them to have. And then what we can do is now getting the parameter u and v from this node. Which are those two, right? So we just need two commands, get attribute command. So let's do that here right away. So u value will be mc dot get attribute Okay, we're getting the attribute of the closest point on mesh. We're getting the one called results. Okay, and then dot parameter u. Okay, that's because that parameter u belongs to the result. See that? You can also see that here if you do the connection by dragging. See, the name of the attribute is called the oh, you can actually do that. Connect parameter u directly, I think, but you can also do the result thing. I think I'm overthinking it. So yeah, we're getting the attribute of that as u value, and then let's paste again. This time we're gonna do v value will be equals to parameter v. Okay, now after we getting those two values, we can delete those nodes that we created earlier because they're useless now, which are the locator and then the close point on mesh. So let's do that here. MC dot delete. Okay, and we can delete the geo shape. We can just copy it, and then not the geo shape, sorry. Gonna delete the closest point on mesh. Sometimes I don't know what I'm saying. The locator. Okay, delete those two, the closest point on mesh and then the locator. So those two are gone, and then we can return the result we're getting. So return u and v. Okay, so let's make that equals to uv, and then let's print out the uv. You see, now we're getting the correct uv, 0.27 something and 0.851. That's the closest uv coordinate for that vertex. I don't need those two either. Or that. Alright, so now we have two functions now can gather the information we need. Now it's time to really do something. Let's create the last function we need, which is make controller follow scan. Okay, now let's define this function. Now the function will need some argument. The argument we need is actually just the two argument, which is the geo. Geo, and then the controller. Okay. So let's do some function calls. The first function call is let's go get the closest UV coordinate. So UV will be equals that. Okay, then that will be the closest point UV coordinate from the controller to the geo. We just need to pass in those two arguments. Okay. Now let's then create the follicle. Let's do the follicle translation. Translation will be equals the create follicle. Okay, we need a couple things. The first thing we need is the geo, which is the same geo here. And the UV coordinate will be our UV, the first one, and then UV, the second one. Okay. And then follicle name base. Let's use the controller's name for the follicle. and also the geo stem. So geo plus maybe oh, let's type in follicle first. Follicle underscore geo name, and then maybe the controller name. So that way it's supposed to be unique if the controller's name is unique and the geo's name is unique, and then the follicle name will be unique. Okay, so this is follicle on the geometry, and then it's going to be used to control the controller. And then remember that we returned the follicle, we returned the follicle node and the follicle translation node. We need the translation node, so the second one here. Alright, now before we move on, let's run this code and see if everything works. So this time let's do that for that controller maybe. And then of course the geometry will be the head geometry. Okay, so let's run this code, and what I will have is now a new follicle called the follicle head geo, and then the controller name. And then it also will be following the skin already. Let's do it here and there. Okay, now you see the follicle is there. Okay, so follicle is created, which is cool. Now let's do the other parts. So after the follicle, what we did is we need to group the controller. Let me delete that follicle. So we need to create the control. We need to group the controller, and we need two groups. One is the follow group, another one is the compensate group. So let's do that. And repeat group, and then we're grouping the controller. The name of the new group will be control plus underscore follow grp, and then we're gonna group the controller one more time, and this time the name will be the compensate grp. Okay, now two groups are created, and let's do some controls. The first control will be the point constraint from the follicle to the follow group. So let's do that. Point constraint, and then it's gonna be from the follicle to the follow group. You can directly pass in the name, or you can do follow grp equals that, and then you can use follow grp to refer that, which is supposed to be better that way. Okay, and then let's do the compensate. I'm totally okay with longer variable name and function name because they make sense to me more than a simplified naming. Sometimes you forget what they mean. Anyway, and then maintain offset will be equals to true too. So that's the point constraint we need from the follow, follicle to the follow group. The other thing we need to do is the multiply divide to the other group, right? Let's do that. So let's first create a node, and this time we're going to create that multiply divide. It will be better to copy a name from a multiply divide node, so that way you cannot get it wrong. So let's just copy the name of this guy and delete it. Okay, name equals let's just name it the controller plus md compensate. All right. Now we're gonna connect the attribute. Let's also give it a name. multiply divide equals that. Okay. So the attribute will be connected from the controller to the multiply divide. The controller will be the ctl, right, and plus the dot translate. Connect to the multiply divide node. We're gonna connect it to the input 1. I think that's all lowercase, just in case. Let me just do a connection so I can see the stuff. Other name, so input 1, that's it. And then output should be just output, I think. Okay, output to output. Okay, let's do that here. So the other one will be connect attribute, and this time it's gonna from the multiply divide output. Okay, and then it's gonna go to the compensate group, translate. Okay, so we're connecting the attributes, and then eventually we need to stat the attribute of the multiply divide, and the attribute will be stat. Being setting will be the multiply divide node. Its input 2x x. I think it's the uppercase x. Just making sure. Yeah, uppercase. So uppercase x, y, and z will be all changed to -1. So now we've finished everything. 2 groups, point constraint on the follow group, and then multiply divide node on the other group from the controller to the other group, and multiply divide multiply the translation of the controller by -1, which is set it here, and then connect the results output to the compensate group's translate node. Okay, let me delete that follicle and run this code again. Okay, got an error again. And object name. Oh, I forget a input 2x. I must have forgot something here. Oh, forget the dot. Alright, let's try that again. Okay, now everything should be there. Let's see. Now if I drag, I think I'm doing this one, right? No, that one actually. So now this should that controller should follow the skin now. Okay, and there will be no weird double transformation. So it's working just okay. And the problem here is that we can only do one, right? When we run this code, we can only have one controller being there. So let's make it do more. So we can do maybe just another function to rerun this code every time. So let's call this one define make selected follicle, selected follow skin. Okay, now because we're doing that, let's just make it not needing any argument. So let's do selection equals to MC dot list selected equals true. Okay. Now for every atom in selection. Okay. The first thing we want to know is which one is the head geo. We're gonna do this. So when we select all the controllers here and then select the skin and run the code, it will do the job. So the last thing in the selection will be the atom. So if atom equals selections last one, okay, then we don't do anything, so we continue. Okay, if not, then we start doing something. Geo, first of all, geo will be equals to selection and then the -1, the last one there. Just making sure my naming are the correct ones. Okay, the IDE here is actually quite primitive though. It doesn't give you auto completion on the variable you created. Not like Visual Studio or even Mono Developer is better than that. So it's crap. But anyway, let's keep on doing that. The geometry will equal to that, and then the controller will be the current atom. So let's just do that. Make controller follow skin. Let's do that on every atom. So geo and then atom. Okay, and that should do that should do the trick. So every time when we call this, it will make all our selection to follow the skin. Let me reopen the file here so we can do that with a clean node. Let's grab all the controller here, the primary ones and secondary ones. Okay, that's all the controller and then the skin. Let's run the code. Oh, have an invalid syntax somewhere. Let's see. Oh, need to double equal. Always do that weird mistake. So that has to be double equal. That means actually evaluating if those two are true or not. If you use single equal, that's just assignment. Let's try this again. Oh, another arrow here. That should be no problem. Make follow skin should be okay too. Make selected follow skin shouldn't be having any problem either. Define. Oh, I need a column there. The syntax for different programming language is different, so take a little time to get used to. That doesn't exist in most other languages. Okay. So you need to have a column there to tell the if statement, to make the if statement work. Okay, let's run that again. Alright, now you see a whole bunch of follicles created. Let's group them together. Let's call this facial follicles grp. Okay, now hide it. Now if I go drag my controller, you see now other controllers are now following with it, which is pretty fantastic. Okay, so that's the basic idea of using coding to help you do something automatically. You see now you just need to select all the controller and then the skin and run this code, and everything will be there. Okay, and so that's the coding part. And if you can do the coding and then give me a UI, by that what I mean is, let me pause it and do my UI so I can show you what that looks like. Okay, so I finished my UI. It's just a very simple UI. It lacks it. So all you have is just a button here, make follow skin. And what it does is, does the same thing. So primary and then secondary controllers. just grab the controllers and then shift select the skin and then press the make follow skin. What it does is now creating those follicles. Okay, I think it would be better to actually group those follicles eventually. Special follicles, GRP. Okay, and this code will do that for you, and then you can just start dragging the controllers. Now you see they're just you want to hide it because you may accidentally select those follicles instead. But anyway, so the result is now those controllers will follow the skin. Okay, so the core code is already done. All I need you to do is do the UI part. Oh, I'm selecting the follicle again. Okay, you don't want to select the follicle. It's gonna cause a lot of problem. But yeah, so with those controller now following the skin, it just feels more intuitive. Although there is literally no difference between before and now, mechanic wise, but it just feels much better with the controller follow the skin now. So, and you see how coding is really useful in those all kind of repetitive stuff. Joint-based facial expression needs those kind of coding to automate some of the stuff, like creating curves, ribbon, because it just takes so much time to do and they're repetitive and they're actually boring to do too. So I highly encourage you to learn some coding if you want to be a rigger in the future. Coding is inevitable, and you have to be able to do more or less at least this level coding, so you can make some of the progress automatic. There are other kind of coding to even do more advanced stuff, like you can create your own data structure to store things, like even your set-driven keys and stuff, to simplify the process. All sorts of interesting classes you can create for controllers. You can export and import your assets too, which is also could be another topic we can talk about later. But for now, I think it's probably a good time to start learning some coding, not just for rigging. Maybe it's for like everything in the future. Like you're creating game, you need scripting, right? Some scripting knowledge in animation is also useful. Like you can make your keying easier by write some simple coding to create key offsets or create in-betweens easily, and then maybe some of the favoring thing. Okay, so it's pretty useful on all aspects. And that one time I actually coded something to fix some student's frame rate problem. So he has the different naming of the frame padding, so I used some C++ coding to automatically fix that problem, because there are so many keys, so many frames, you don't want to rename them. You certainly don't want to re-render them either. So coding is really useful. So okay, that's for today, and again, extra credit, 5 extra credit if you can make this finished program work like this. Okay, just one button and that's it. So thanks for watching, and I'll see you next